So as you can see, I've already created a project for myself, and the reason why I didn't do it as a part of this video is because I don't want to be doing things that you already know how to do. So let's talk about variables. This is a very fundamental concept because in our programs, we will always want to store data, then be able to retrieve that data and do something with it. This is what variables allow us to do. However, since C# is a strictly or strongly typed language, that means that our variables should have types. So when we are creating or declaring our variables, we should specify what type of data we're trying to store in them. For example, we might want to store numerical data in some variables, and then we might want to store textual data in some other variables. Then there are different types of numerical data, such as integers or decimal numbers. We also need variables to be able to save more complex structures as well, but we'll talk about those a little later. So let's create some variables. I will go ahead and say string some text equals here is some text. Now let's go over the format. First, we have our type. So this is the type for the variable, and it says string. String allows us to store textual data. And string is a reserved keyword, meaning that it's part of the language. If it's misspelled, it won't be recognized and your program just won't run. It won't be built. So let's say if we just remove one letter, see it's underlined red, meaning that it is not being recognized. And another good thing about the IDE is that you get these quick feedbacks, which allows you to fix any errors right there and then. So we'll just bring it back and say string. Now it's recognized. And it has to be exactly the way it's written here. So then after that, it comes the variable name. And this can be anything you want, but you want to keep it descriptive so that you understand what it's storing inside. Then we have our assignment operator. We'll go over operators in our next video, but all you need to know is that it takes the value on the right side and assigns it to the variable on the left. And then we have the actual data that goes inside of the variable. So there you go. Now let's declare another variable. I will say int number equals 10. Int is another type which allows us to store whole numbers. For example, if I try to say 10.9, which is a floating point number, it won't work because the value is not compatible with its type. If I want to store a floating point number, then I have to use the appropriate type. One of the appropriate types would be double, and I can say another number equals 10.9. See, in this case, I have the value compatible with its type, and that's why it works. Let's go ahead and write another one. I will say bool is ordered equals true. And bool is a very interesting type because it allows only two types of values, true or false. And another thing is that whenever you're naming your Boolean variables, you want to keep the name so that it's either asking a question or verifying an idea, because that way it's a lot more intuitive. Now the next one is very interesting. We're going to learn how to get input from a user, and we're going to do that with a pre-written class and a pre-written method that is accessible to us. It's called console readline. So the console is the class and readline is the method. And we'll go over classes and methods later down the course, but for now, what I want you to know is that this is available to us and many other methods and classes. They're pre-written and we have access to them right out the box. So this will allow us to get the input from a user, but now let's store it in a variable. One thing to note is that whenever we're getting an input from a user, it always comes back as textual data. So what is one way we can store textual data in a variable? Exactly, string type. So what we can do is we can say string input equals console readline, meaning that the console readline will get the input from a user, then it will save it inside of the variable. And that's great. Let me show you another one. Var anything equals 10. Interesting, right? It just worked. What if I do this? Still works. What if I do this? It still works. So var is an implicit type, meaning that anytime you assign a value to it, it automatically figures out the type, meaning that you don't explicitly have to specify the type. That's why it's called an implicit type. And it's very good to know as we're writing more applications. It's actually very, very useful. So now let's go ahead and print the values within our variables. We're going to do that using another pre-written method that we have access to called WriteLine. And it's also in the same class called console. So we're going to say console, WriteLine, and then we're going to say some text. Now let me do the same thing for number. Another number is ordered, input, and anything. Let me copy the names real quick. There you go. And then I will breakpoint this. So a breakpoint allows us to break the execution flow of the program. Basically, what happens is that whenever we run our program, it starts executing statements line by line. And when we breakpoint it, it stops at that current point and shows us the current state of the application. So I'm breakpointing at the very beginning, and then I will manually step through each and every statement. Now let's go ahead and click Start. And Start, what it will do is it will build the application first, and we've already went over what building does. So it will build the application, then it will run it. So let's go ahead and do that. And see, since I breakpointed it, it stopped right away. And then I will click Step Over, which will step over every statement manually. So we'll go here and see here, it shows us the current state. So it says some text equals here is some text. So we can see the variable and their values. Now let's go all the way to input. See, it stopped. That's because it's waiting for an input from the user. So I will say, this is me. And see, it went to the next line because I got the input from the user. Then I will print all of the values. And let's open it up. See, it says, here is some text. That's here, 10, which is the number, 10.9, which is another number, true, which is ordered, this is me, which was the input, and then 10.9, which was anything. So that's great. One more thing to note is that there's actually a lot more built-in types that I didn't go over, but the reason is because, number one, it will be extremely boring for you to watch me go over each and every type separately. I'm pretty sure you already got the point by the third or the fourth one. And the second thing is that I strongly believe it's much more important to understand the general concept behind all this than to memorize specific things. So I'm pretty sure you already understood the concept, and since you understood the concept, you can then apply this same thing in your specific situation. So if you need to learn about the rest of the types, you can simply go to Google and then type in MSDN C# built-in types. I already have that. And then you can click on msdnmicrosoft.com and it'll give you all the built-in types. Now it's very nice because we already know some of them, double, int, right? And you can click on them, and I want to show you something. See here, it says range. So an integer, this is the range of values that it can hold. So see, if we put anything that's above it, it will break. Let's go check out double real quick. See, the range is much larger, so it's giving us a lot more precision. So that's actually very good to know if you're writing an application that is very scientific and you need to know how large your value should be, so how much memory you need to allocate for it. But once again, since you know the concept of a variable, now you can apply it in your specific situation. And once again, variables are just a way for us to store values and then retrieve them and do something with them afterwards. And in C#, since it's a strongly or strictly typed language, we need to specify types for the data that we're trying to store.